Okay, last bit, or the last video anyway, is the look at the objective and to show you the kind of the one new piece that we're looking at today, or the additional level of complexity, and that is the distributive property. So here we go. Um, Objective: I will multiply a mixed number factors and show how it relates to the distributive property and the area model. Okay, so here's problem one. And all it is, and what you're going to be looking at, is some rectangles. Yesterday we measured them, and since you didn't have, you may or may not have had a ruler. We only really studied part of what we needed to study yesterday, but that's okay. Today we'll be able to do the whole lesson, or kind of meet all of the objectives that we want to meet. I want you to meet. All right, so this is a rectangle that is 3 3/4 inches by 1 1/3 inches. You can find the area lots of ways. I want you to look at the area model here. Okay, so if we did the area model, we would do 1 plus 1/3, 1 plus 1/3, something like this, and 3 plus 3/4, something like this. That was terrible, because then, yeah, this should be a little small piece, right? Okay, so 1 times 3 is 3, so that's 3 square inches. 3 times 1/3 is, well, 3 times 1/3, that's 3 divided by 3, that's 1. So 3 1/3 is 1. 3/4 times 1 is 3/4. These are all square inches now. I just don't have room to label them. 3/4 times 1/3 is, let's see, 3/12. 3/12 is 1/4. Okay, and then we would just add those up, right? Kind of, when we did it back in earlier modules, we added across. So this would be 4, in this case, square inches, and this would be 3/4 and 1/4 is 1. So 1 square inch, and then add those together, and you get 5 square inches. So the area of this is 5 square inches. And I mean, really, what have we got? We multiplied 1 1/3 times inches, times 3 3/4 inches. Put that back up here. And we got 5 square inches. What I want you to see is, how did we do that? How do we do that? We did it by taking all of these apart. We said first, well, here, let's do it this way. 1 times 3. So this is just the distributive property. 1 times 3 plus 1/3 times 3. So 1 times 3 plus 1/3 times 3 plus, I'll put it down here, so it's kind of like an arrow there, plus 1 times 3/4 plus 3/4 times 1/3. So what I want you to see is, this process, when we worked on the area model here, we were just doing the distributive property. We were just pulling these apart. So here was 1 times 3 is 3. 1 times 3. So that's the distributive. So that's this 1 times this 3. 1/3 times 3. 1/3 times 3. That's 1. plus 3/4 times 1, 3/4 plus 3/4 times 1/3, 3/4 times 1/3, 3/12 is 1/4, right? So each of these, and let me take this a little bit, this is messier than I want it to be. So each of these, and I'll put it down here, 1/3 times 3 plus 1 times 3/4 plus 3/4 times 1/3. So if I take these, what do I get? I get 3 and 1 and 3/4 and 1/4. And what do I get when I add those up? 5. And then if I keep in mind, I guess I sort of lost track of the inches part, but if I keep it in mind that those were, these would be square inches. So inches squared, inches squared, inches squared, inches squared. So this is 5 square inches. All right. So I want you to see that what we have done, an area model is another way of thinking about the distributive, or essentially you're thinking about the distributive property. Do I want to do problem 2? Well, let's see here. All right, so yeah, let's do problem 2. I'm going to zip through it though. So problem 2, and then I'm going to ask you to do a bunch of these on your own, or a couple of these on your own. So we have a problem 2. We have a rectangle that is 16.5 by 4 1/4. So 16.5 by 4 1/4. I could just use the area model, right? I could say 16. What are these? These are inches. 16. There's a half. I'll pull that apart. 4 1/4. So let's say 4 goes down to here. 4 1/4. Just use the area model. 4 times 16, 64. So that's 64 square inches. 4 times a half. Half of 4 is 2. 1/4 of 16. That's 4 square inches. 1/4 times a half. 1/4 times a half is 1/8. Adding those up, 64 and 4 is 68. 68 and 2 is 70. 70 and 1/8 is 70 and 1/8. So what is the product of 16.5 inches times 4 1/4 inches? Well, it's 70 and 1/8 square inches. That's one way you could do it, right? You could also go through the distributive property the whole way through. 16 times 4. Well, by the way, that's what we just did. 16 times 4. 16 times a half. 16 times 4. You could do it that way, but 16 times 4, 16 times 1/4. 16 times 4, 16 times. Oh, that's right. Did I make a mistake on my? Yeah, it's 4 1/4. Yeah. Okay. Let's try that again. There we go. So 16.5. All right. 16 times 4. 16 times 1/4. Plus 4. I'm sorry. Plus. I just got totally distracted here. 16 times 4. 16 times 1/4. 1/2 times 4. Yeah, geez. 1/2 times 4 plus 1/2 times 1/4. (16 times 4, 16 times 1/4. 1/2 times 4, 1/2 times 1/4. Yeah, okay. All right, which, by the way, is what we just did, right? And 64, except, so area model, distributive property. Uh, 64 plus 4 plus 2 plus 1/8. We already know, well, 70 and 1/8. And we've been doing square inches. And then finally, I mean, could you also just turn these into improper fractions? Just turn 16.5 and 4 1/4 into improper fractions and multiply those? Sure. So let's take that. And we'll just say, so really we've got like 3 strategies here. 1, 2, 3, even though these basically feel the same to me. 3, multiply improper fractions. And I'll just show you how to start. So 16.5 inches times 4 1/4 inches. So that is 33 halves times 17 fourths inches. And then you could, darn it. And then you could go on and answer that. And so remember, I've told you many times, and I'll tell you again, there's, be proud of knowing multiple ways of doing a problem. So, I think a lot of you could have gone right to that improper fraction. Some of you may have gone right to distributive property. Some of you might be very comfortable with area. But if you know all 3 ways, then you know more, then you're doing better. Okay? All right. Now,